Students, good morning to all of you. Students, in today's class, we understood about error of measurement. As we know that for comparing the quantities, the measurement is necessary. That means the process of measuring of a physical quantity is essential for comparison. Okay, so whenever we measure the quantity, there are two different values. One is a true value, true value, and another is measured value, measured value. Okay, and the difference between the two is determined as error. Okay, maximum time it is observed that the measured value is near to true value but not exactly same as the true value. For example, uh, one can measure length of a thread is 2.5 meter. Another can measure the length of thread is 2.47 meter. Another one who is measured as the length of thread is 2.52 meter or similarly, and the actual length of the uh, thread is 2.48 meter. So you can easily observe that this is true value and these are the measured value, which means we measured the quantity very near to its true value. Now the difference between the two values, one is true value and the measured value, is termed as error in measurement or error of measurement. Okay, basically the errors are three types: systematic error, random error and gross error. Systematic error are categorized in sub four parts like personal error, instrumental error, uh, imperfections of error, and the mm, error due to external causes. Okay, so these are some systematic error. Then after we define the random error as the error which occurs irregularity due to the unpredictable variation of the experimental values. These are the random error, and the gross error is these error arise on account of the sharing carelessness of the observer. Many times many times the observer assume that the, for example, from the seam the actual length of the thread is 2.48 meter, but the observer assume it is not 8, it is 7, which means 2.7. Another observer experience it is 2.5. Another one is observed at 2.52. So these are actually the gross errors in the measurement. Okay, now whenever the measurement is occurred or error is occurred in the measurement, we use the method to reduce these error by calculating their absolute error, mean absolute error, relative or fractional error, and the percentage error. Now we understood about the method to calculate the errors, and then after we find the error in propagation. Absolute error in the measurement of a physical quantity is the magnitude of the difference between the true value and the measured value of the quantity. Suppose the quantity is measured n time, where let the measured value are a1, a2, a3 up to an. Therefore, we calculate the average or arithmetic mean. Mean of the values. These values, that is am is equal to a1 plus a2 plus up to an divided by n. This is the mean of the measured value. Therefore, absolute error in the measurement is del a1 is am minus a1, del a2 is am minus a2, and similarly up to del an am minus an. Okay, therefore we calculate the mean of the absolute error. Therefore, mean of absolute error okay. So this is the absolute error. Okay, this is how we calculate the absolute error. Second, we have mean absolute error. Okay, so it is very simply defined as the arithmetic mean of absolute error is, it is mean of absolute error in the measurement. That is mean absolute error is equal to mod of del a1 mod of del a2 and up to mod of del an. Okay, divide by n. This is mean of absolute error, or we can also say that mean of absolute error is equal to 1 upon n summation of del A. Okay. Next, third one is, 1 minute. When we calculate the mean error in the measurement and the absolute mean error in the measurement, therefore we can calculate the final result in measurement. Final result in measurement. Of a quantity. Okay, is, suppose we measured here the quantity A, therefore this quantity A is measured value result is given by arithmetic mean plus minus del A mean. This is actually the measured value. Is here it is indicate that A is, or we say true value of A is lie in between A m plus del A mean to A plus A minus del A mean. Okay, this is the result after that, the measurement. Okay, now next we have the relative or fractional error. Third one is relative or fractional error. As you easily observed from the name, we can define as relative error of measurement is defined as the ratio of absolute error, mean absolute error to mean error. Mean error, that is relative error is equal to mean absolute error upon mean error. Okay, that means relative error is equal to del A mean upon AM. This is the relative error in the measurement. Next is fourth part is percentage error. It is simply the relative error percentage. Error percentage is equal to this is how we calculate the percentage error in the measurement. Okay, so these are the methods to calculate the error in our measurement. Okay, now we understood about the propagation error or error in the operations. Okay, we have in mathematics 4 rules. First is addition, second subtraction, third multiplication, and fourth division. Okay, so whenever we use the operation, mathematical operation in our measurement, the errors are propagate from each and everyone. Okay, now we understood about the propagation of error. First, in addition. Okay, let's say we have a quantity. Let a quantity, a physical quantity, is expressed as x is equal to a plus b. Okay, now if del a yes, if del a is error in a, error in measurement of a, of A and del B is error in measurement of B. Therefore we observe that we get del X is error in measurement of X. Okay, that means that is X equal to A plus B. Here we can say that A is measured as A plus minus del A, B is measured as B plus minus del B, and X is measured as X plus minus del X with their errors. Okay, therefore by using these values here we get X plus minus del X is A plus minus del A plus B plus minus del B. Okay, now when we take it separately with error and their exact value, we get X plus minus del X A plus B plus minus del A plus minus del B. Now these are the exact relation. Now we take out from here the errors in the measurement. Therefore plus minus del X is equal to plus minus del A plus minus del B from that. Now we take out plus minus common from here, that we get del A plus del B equal to plus minus del X. So this is the error in addition. Okay. Done. It is very clear that the error is in addition is equal to the sum of error in individual quantity. That means error in addition is sum of error in individual quantity. Quantity. Okay. Note it. Next, error in subtraction. Let a physical quantity is expressed as X is equal to A minus B. Now if del A is error in A, that can be written as this way, B in this way, and therefore the X have error which can be expressed as X plus minus del X. Now from equation first, we observe that X is equal to A minus B. By using these three values here we get this relation, and then this X A minus B is the value which we need to calculate earlier. That means you can use the value x is equal to a minus b here, then you will get this is cancelled. Just I will show you. A minus b plus minus del x equal to a minus b plus minus del a plus minus del b. Now you will easily observe here, this cancel with this, and we left with plus minus del x equal to plus minus del a plus minus del b. Clear? That I am using here. So you will get again error in subtraction. Subtraction is sum of the error of the individual quantity. Okay. Okay students, next we have error in product. Okay, let a quantity, physical quantity, is expressed as x is equal to a into b. Okay, so this is first equation. Now if del a and del b are respectively errors in measurement of a and b, therefore del x is error in x. Okay, as a propagation error. Okay, now therefore a can be written as a plus minus del a, b can be written as b plus minus del b, therefore x can be calculated as okay, x we need to calculate here. Okay, now yes, x can be calculated as x plus minus del x. Okay, now from first we get here, in place of x, or x plus minus del x equal to a plus minus del a. Okay, we can write this in such a way. Therefore 1 minute, here in place of plus we get the multiply, as a this and b this. Okay, now we take from x common from here, we get 1 plus minus del x upon x. Similarly a 1 plus minus del a upon a. From here b is common, 1 plus minus del b upon b. Okay, now we can write it in place of x, AB 1 plus minus del x upon x, and here A into B 1 plus minus del A upon A into 1 plus minus del B upon B. Okay, now you can easily observe here that these value is cancelled, and 1 plus minus del x upon x, and multiply here, this we get 1 plus minus, when this one multiply with this we get del B upon B, plus minus this multiply here del A upon A, and plus minus when this multiply del A upon A into del B upon B. Okay, now this cancel, and we get del x upon x plus minus del B upon B plus minus del A upon A. This we get actually the formula, and here as del A and del B are too smaller than A and B, therefore product of del A into del B also very small, very small. Therefore that is, here I will just write a term 1 2 3 T3, term T3 is ignored. Okay, therefore we get this relation. Now plus minus del x upon x is equal to plus minus taken as common, and we get del A upon A plus del B upon B. This is how we calculate the error in product or multiplication. Okay, next we have division. Okay students, next we have error in division. Okay, let a physical quantity is expressed as x is equal to A upon B. Therefore it can be written as x is equal to A B to the power minus 1. Okay, now if A and B are the respectively error in the measurement of A and B, therefore del x be the error in x as the propagation error. Okay, next then we can write A as A plus minus del A, B as B plus minus del B, and C as x as x plus minus del x. Okay, now from equation first, as x we can write this, and the value of a and b by putting this way. Now when we take out common from x, from these two terms we get this, from here a we get this, and from here b we get this, because the whole bracket have power -1, so b get -1. On solving this you can easily observe this is cancelled and we get this relation, and this is the error in required relation. Okay, this is the error in division. Basically student, the error in division and the error in multiplication is same. Similarly the error in addition and the error in subtraction is same. Now last we have error in power. Okay, error in powers. Okay, so let a physical quantity is represented as x is equal to a to the power m, b to the power n, c to the power l. Okay, therefore you can write it like that, x is equal to a to the power m, b to the power n, c to the power minus l. Clear? Therefore you can easily calculate this in the same manner. Then you will get the error in del x upon x, which means error in the measurement of x. With this is m del a upon a plus minus plus n del b upon b, and because it is negative so l del c upon c. This is how you can calculate the error in powers with multiple operations. Suppose you have a relation time is equal to 1 upon 2 pi, time is equal to 2 pi under root L upon G, and here you need to calculate the error in G. Error in small g. So first you need to square both sides, that means t square equal to 4 pi square and L upon G. Now calculate the relation in the term of G. You will get this relation is 4 pi square L upon T square. It is very clear student that 4 pi square is a numeral value, numerical, it will be constant. Now we just understood about G is equal to L upon T square, which can be written as G is equal to L T minus 2. Okay, now the error in G is plus minus G upon G is equal to plus minus del L upon L plus del L upon L, and here is negative, so minus 2 del T upon T. This is how you can calculate 1 minute, plus 2 upon del T. Okay, this is how you calculate the error in G, which is given by this formula. Thank you. These are some method to reduce the error, and then after In the next class, we understood about some numericals based on the error and measurement. Thank you.